Right? Yes. Right. Today our topic is to learn about what the y equals to ax plus b over px plus q graph. This is our topic today. Right. Basically, if you come up with a shape, you can see it can be a shape, one of this shape. You can see there is a vertical horizontal axis of asymptote and a vertical axis of asymptote. It has a horizontal axis of asymptote and vertical axis of asymptote. It can be a shape like one of these shape because it depends on the equation of the shape. You can understand the situation just like this. Sorry, or this one or this shape. It can be either like this or this. Okay, that is the basic concept, basic shape where we need to understand in under this graphical representation. Right, we'll go ahead with this. We'll try to understand from an example, just like this. Example one. Then if it is a graph like this, x plus 2, I'll get, I'll get 3x plus 2 divided by 6x minus, we will get 18, somewhere like this, right? Okay. Initially, what you need to understand is when you're working out with this, we need to find out what is the vertical axis of asymptote. Vertical axis of asymptote. When you're dealing about the vertical axis of asymptote, simply we can make the denominator into 0. Make the denominator into 0 and obtain the vertical axis of asymptote. So x equals to 18 divided by 6 turn up to 3. Right. We'll start from there. Then it's just like this. So this is x equals to 3. So we can start from here. Right. Then we need to find out horizontal axis of asymptote. Asymptote. When you're discussing about the horizontal axis of asymptote, it's pretty simple. The equation is y equals to coefficient of x on numerator divided by coefficient of x on denominator. This is a format for it. Then you can write this is y equals to, what is the coefficient of x in numerator is 3 divided by coefficient of denominator x in denominator is 6. So it's turned up to how much? Y equals to 1 over 2, right? Then we can draw that line. There is not should be drawn for the scale, straightforward again. 1 over 2. Right. That is the fact we need to get it. Right. Then after that, we need to see whether intersection with x-axis. Intersection with the x-axis you can make by y equals to 0 in this equation. So you can write 3x plus 2 divided by 6x minus 18 equals to 0. So if you just multiply with that, you can say if you cross multiply, what you get here is 3x plus 2 is equals to 0. That is x equals to minus 2 over 3. Right. Then it meets the x-axis at minus 2 over 3. Somewhere over here. Minus sorry, meet the x-axis. Sorry, I just made a mistake. Minus 2 over 3, it's not here. It's here, minus 2 over 3. Okay. Then we need to find the intersection with x-axis. Intersection with the y-axis, sorry. Intersection with the y-axis you can make by y equals to 0. If you make the y equals to 0, you can say, yeah, sorry, intersection of the y-axis means x equals to 0. I made a mistake here, x equals to 0. So you can say y equals to 3 times of 0 plus 2 divided by 6 times of 0 minus 18. So it's turned up to y equals to minus 1 over 9 would be the value for that. Meaning you get the answer y equals to minus 1 over 9. Then you can say the graph should travel through these 2 points. Whereas if you compare to the shape of the graph, it should be which way? It should be somewhere like this way. It should be somewhere like this. So you can draw the graph. I'll just draw it. It's like this way around. Then you can draw nicely like this way. It's like this, and this would be the shape of the graph for that. That's a way of understanding this situation. Okay, right. Then we'll go ahead with another example. Go ahead with this. The second example, y equals to, if it is a shape like this. 4 minus 2x divided by 3x plus, we will get, we'll get 3x minus, we'll get 6. Yeah, right. Then initially we need to find the vertical axis of asymptote. Vertical axis of asymptote. Vertical axis of asymptote, how do you get it? You can make the denominator 0, this one. 3x minus 6 is equals to 0. That is x equals to 2, right? Okay. Initially, we'll draw this. Then we can work out horizontal axis of asymptote. Horizontal axis of asymptote we can get by y equals to coefficient of x in numerator. It's how much? Minus 2 divided by coefficient of x in denominator. It's how much? 3. Then that's it. So it's turned up to y equals to minus 2 over 3. It's 2 over 3, right? Then we need to see whether the graph meets x-axis. Yeah, the graph meets x-axis means y coordinate is equals to 0. That is 4 minus 2x over 3x minus 6 is equals to 0. With this you can say 4 minus 2x is equals to 0, x equals to 2. X equals to, there is a issue seems to be. See, with the no, that's but a small issue. I just want to change this. You don't get the answer because it's then it just simplify and turn up to just a straight line for it. I just make a small change over here. I just make them into 3 with it. 3, then this is yeah. Then over here only the change comes, so it's minus 3 over 3. Minus 3 over 3 is equals to minus 1. So I'll just make this as -1, -1. Then y equals to 3, 0. So this is 4 minus 3x. This has to be -3. So x equals to 4 over 3. So x equals to 4 over 3 means somewhere here. It's less than 2. It's 4 over 3 somewhere here. 3. Then we can say meets y-axis. Meets y-axis means x coordinate is 0. So you can say y equals to 4 minus 3 into 0 divided by 3 times of 0 minus 6. So it's turn up to 4 over minus 6. That is minus 2 over 3. We can say it's minus 2 over 3. It's a point somewhere here. Because it should be greater than -1. So here only you get minus 2 over 3. This is a point. Then you can draw nicely. The graph should be travels through these 2 points. It's like this, and just my drawing is a little bit of crooked at that point. So it should be a shape like this. Just make it smaller. Then that is the 2 different shape of the graph. That is a basic fact where we need to learn about this kind of a graph. Right. Okay. Right. Then the next fact we need to understand is, we'll get a new page. The next topic comes with range and domain y equals to ax plus b over cx plus d graphs. From an example, I will obtain the graph for this. So if it is just like this, if it is given y or fx, so already in terms of fx, it's kind of easier for me to make it. Fx, I'll get the first example itself. That was 3x plus 2, 6x minus 18. 3x plus 2 and 6x minus 18. When you draw this graph there, you obtain, it's just like this. There's a vertical and horizontal axis of asymptote. So y equals to half and x equals to 3. And y equals to half. Right. When you refer with this graph, yeah, we'll come up with this. It was, as I remember, it's just like this. Okay. Then when you are referring to the domain for this graph, right? Domain means what is that? The input value. You can say for the input values, it includes all of these x values except what? Except 3. There is no answer for 3. Therefore, the domain would be, you can say, x is any real number, and you can say x is not equals to 3. Except 3, all other values can be obtained for as a domain. Then range. Range means the y values. Range. For this graph, you can see, all the y values, you can say the y values are accepted for all values are there except half. Now you can see if I just draw this graph, it comes like this. It comes to this end over here. There is the value half is not there, and all other y values are available for this graph. So you can say the range become how much? You can say y is y or fx. You can write here, it's mentioned as fx, therefore write fx is any real number, and you know that fx is not equals to half. Except half, all other y values are accepted for this function. That's a fact we have to understand with this kind of a graph, right? The same graph, sometimes they might be given in this format. This is a second approach for this graph. They might give you fx is 3x plus 2 and 6x minus 18, and they used to give us x is any real number and the domain is given to them. X is greater than 4, greater than or equals to 4, or greater than 4, even doesn't matter. Now you can see if I refer with this graph, they ask you to find range. Find range. That's a question where in our hand. Right? So you can basically understand the graph. We have to draw the graph. Y equals to half and x equals to 3. Therefore, the graph is like this. I just plot the graph. The entire graph is like this way around, but there is something further we need to understand. But you know that x is existing for more than 4. 4. If I just put the value for 4 for this graph, you can say f4, it's like this. It's 3 times of 4 plus 12 divided by 6 times of 4 minus 18. 12 plus 12 is 24 divided by 24 minus 18 is 6. It's 4. It's 4. So you can see the graph is more than 4. So the x values are just over here. X values existing from starting from 4 above only. These are the x range. Then therefore the graph is only this bit. Not the entire stuff is there, including 4. This is the shape of the graph. Only this part of the graph is available, not the any other part of the graph, because other part is not there, because the x is including from here to here only. Then what is the range of y then? You can see the y values are starting from 4. 4 is included because that 4 value is there. It goes down, but it never turn up into half. But it never turn up into half. Therefore, the y values would be, you can say, fx is any real number, and you can say fx is, there's a range for fx. Fx is greater than half. It's half is not included, less than or equals to 4. Because 4 value is there, but it goes down, but it never turn up to half. Therefore, it's ended up with half. Half is not included because it's an axis of asymptote and 4 is there itself. That's a way of understanding this kind of a graph, right? Okay. I'll give another shape of this, whether how does this ask with, yeah, if the question is in this format, they might give you fx is equals to 3x plus 2 over 6x minus 18, and they have given x is any real number and x is less than 3. X is less than 3. That's a fact they have given. So if you sketch this graph with it, because I'm explaining from the same graph, it's easier to make it understand clearly. Half, and this is x equals to 3. Now the shape is this. And it's like this way around. And they mentioned what is the available exchange. Available exchange for this function is less than 3. Less than 3 means from here less than this. This is the range. Sorry, this is the, sorry, that is the domain for this function. Then what we can understand is during that range, what would be the y value? Over here, the y value is somewhere here. When it come up over here, the y value varying from the graph exists only this bit, not the other dotted part. So the graph is only drawn from here to here with that. Only here to here. Right. Then what is the y range then? The y values. Then if I use the red color, y values would be, it's not half, below than this. Below than this. So all the y values are included into this range. This is a range of y where it includes for this kind of a range. Hope you can understand. There with that, You can say this answer, fx is any real number, and you can say fx is less than half. Y value is less than half, it goes to infinity. There is no lower boundary for that. That kind of a graph, even we should be able to identify this kind of situations. That is the next part of this graph. Right. Then the same graph, the last part of this graph is like this. They might give you fx is 3x plus 2 and 6x minus 18. They might give an x is less than equals to r, and x is in between. They might give you the values from x should be greater than minus 2 and less than 4. Right. This is little bit contradictory. Right. We'll start with the graph. Right. X equals to 3 is a 1 point. Other point is y equals to 1. Y equals to half, right? Then the shape of the graph is, it's like this. So the shape like this. Then we know that function exists at minus 2. So initially I find f minus 2. Minus 2 is 3 times of minus 2 plus 2 divided by 6 times of minus 2 plus minus 18. It's minus here. Minus 6 plus 2 is minus 4 divided by minus 12 minus 18 is minus 30. Let's turn up to then minus 12 15 1 yeah, 4. Let's turn up to 2 over 15 today. 2 over 15, it's a value somewhere like this today. 2 over 15. Then the other boundary of it, f4. We already found this f4 value over here. Therefore, I'm not going to do it again. f4 is again 4 today. 4 is 4. So if I just mark the value for 4, this is minus 2. 4, right? Now you know that what is the x range? X range is starting from where? Minus 2 and it goes till where? It goes till 4. Now you can see from these values the behavior of the graph. At minus 2 the graph is here. It's like this. It's like this. And up to 4, the graph is somewhere up to here. Okay. Now let's draw the y values, the respective y values. Over here the y value is this. When you come up over here, the y value goes like this. Therefore, you can say fx is any real number, and you can say fx is less than or equals to 2 over 15. And from this shape of it, it's here and it goes up like this. So the graph behaves somewhere to here. So it should be greater than or equals to 4. Okay, you should be able to write this definition as well. Those are the approaches of this kind of a graph when we're analyzing y equals to ax plus b plus cx plus d graph. That's a way of getting the shape of this. I'll just make a page view, then you can have a clear idea on that. Yeah, that is the shape. And basically these are the shapes we need to analyze, and this is the way, if they are referring with the domain range and domain for this, we should be able to understand how to get the range for this. Yeah.